Good morning. Today we are going to see some problem related with beams. We are going to consider three loads, and for these three loads we are going to solve the problems. Three loads we have in your syllabus. We have concentrated load. So problems related with concentrated load only. Then we have UDL, and then we have couple moment. So now we have first beam, analyze the beam loaded and supported as shown in figure. So we have beam AB, that is 100 kilonewton, that is at center. Support A is simple, support B is roller. Now this is given beam. So we have given beam. Then we have to draw FBD of beam. So as support A is simple, so we have two reactions at A. One is horizontal as HA, second is vertical as V. Support B is a roller, so we have only one reaction, that is RB. Now here we are not writing RA because we have RA equal to root of HA square plus VA square. As HB is 0, so we can write RB as directly RB, or you can have choice, VB also you can write. So we have three unknowns. We are going to use three equations. Fx equal to 0, Fy equal to 0, and moment equal to 0. So moment about any point equal to 0. So three equilibrium equations, three reactions. So we are going to solve for these three unknowns, that is HA, VA, and RB. Now we are going to first write equation summation Fx equal to 0. And we have only HA in horizontal direction, so we will get HA equal to 0. Then we can take moment about A0, because if I will take Fy 0, then we have two unknowns, VA and RB. Instead of this, I will take moment about A0. And from this, we are going to get 100 into 3. That is distance between A and 100 kilonewton clockwise, so plus, minus RB into 6, and that is equal to 0. So RB into 6 is 300. RB we have 50 kilonewtons. Then we will apply Fy equal to 0, forces in vertical direction. So we have in vertical direction VA, then we have 100 kilonewton, and then we have RB. So we have VA minus 100 plus RB equal to 0. And from this we will get VA 50 kilonewton. So we will put these values, VA 50 kilonewton, HA 0, and RB again 50 kilonewton. So this is solution of this problem. Then we have second problem, analyze the beam loaded and supported as shown in figure. Then again we have 7-meter beam and UDL is 3-meter central portion. So as this is UDL rectangular one, so we have this value as 50 kilonewton per meter, and we have length 3 meter. Total load is area of this load diagram. So we have 50 into 3, 150 kilonewton. So we will have first is given beam, and then second we have, that is FBD of beam. So in examination, you can directly go for FBD of beam. You need not require to go for given beam. And then again, we have two reaction at support A and one at support B. Then we have to use summation Fx equal to 0. And by using summation Fx equal to 0, we are going to get value of HA, that is equal to 0 again. And then we have to go moment about A0. So we have 150 into 3.5, because we know as it is rectangle. So our total load will act at center. This is 1.5 meter. And then we have this as 1.5 meter. So total distance we will get from A, and that is equal to 3.5 meters. So 150 into 3.5 minus RB into 7 equal to 0. And from this we will get RB 7 equal to, so we have actually this is 150 into 350. We have this multiplication, that is 525. And then we have RB upon RB upon equal to 522 upon 7, and we will get this value 75 kilonewton. So knowing value of RB, we can use summation Fy0 RB 75 summation Fy0 Va minus 150 plus RB equal to 0 and Va also 75 kilonewton. As values are going to be plus, means whatever direction we have assumed, that direction are correct and we have both in upward direction. So Va is 75 kilonewton. Now we will go with analyze beam loaded and supported as shown in figure couple, and value is 120 kilonewton meter. Span of the beam is 8 meter. So this is again we have given beam, and then we have to go for FBD of beam. So we have to replace simple support by 2 reactions, roller by 1 reaction. Then again we are in the same fashion. We will apply summation Fx equal to 0, and we will get value of HA equal to 0. So now we will apply moment A0. So we have 120 minus RB into 8. Now we have to keep in mind, as it is couple, its unit is kilonewton meter. So I need not require to multiply it by distance. So we need not require to write 120 into 3. No. So we have to write only 120 because RB we have in kilonewtons. And therefore we have kilonewton and we are going to multiply it by distance. So this is kilonewton and this is meter. So this is kilonewton meter. This is already in kilonewton meter. So do not multiply by distance. And that is equal to 0. So RB into 8 is 120. RB is 15 kilonewton. So RB 15 kilonewton. So as it is upward plus, so that means whatever direction we have assumed is correct, that is upward. So now we will apply Fy0. So Va plus RB equal to 0. Now we have to keep in mind Fy means we have force in Y direction. And we know the unit of force is kilonewton. And as we have only kilonewton will be considered in this. So this couple should not be considered because unit is kilonewton meter. So we have to consider only Va and RB, that is equal to 0. Do not consider 120 kilonewton meter. So we will get Va equal to minus 15 kilonewton. So as it is minus, so we have considered this in upward direction. So value is minus, means we have value of Va that is 15 kilonewton and downward. So we have to show Va 15 kilonewton in downward direction. So whatever sign you have shown first, you have to round up that sign and show correct sign. Do not rub this sign, keep it, but make it round and show correct direction. So likewise, we have to solve the problems which are related with beams. Now we will stop here only. Thank you.